Well, first of all, I'd like to say thank you to the organizers and Dr. John in particular for inviting me to talk about my experience. I am Jaimin Trivedi. I am at University of Louisville, Associate Professor and Director of Clinical Research in Cardiothoracic Surgery. I am a medical doctor from India. I did my further training in the US, and most of my work in past 17 years has been in medical devices and heart transplant and clinical and outcomes research in cardiothoracic surgery. And we have been using 3D technology in medicine all the years, and I'm just going to go over my experience of what I have been doing and how it has been so far. First of all, I'd like to state that I have no financial disclosures or any conflict of interest. I'm an academician and I collaborate with industry frequently, so better things come to light. And this was a slide I had prepared, even before I had the pleasure of attending talk from Dr. Negi. And I was hoping that at some point we would have this in our houses, and that's not far, because this is 10 years ago. That's when about NASA gave $100,000 grant to somebody to develop the 3D printed pizza, so they can take it to space and then print it and then bake it and eat it. And the slide on left is basically a cookie being printed by the chocolate. That's how it started. And then eventually it moved to a more precision food printing. That is when I first heard of 3D printing in any sort of food, medicine, healthcare, nutrition side. So that's when I would like to take a little digression to see the theme of this meeting is democratization of technology, and particularly 3D technology. And the great Abraham Lincoln has said that for democracy is basically of the people, for the people, by the people. And particularly for this meeting, I would like to say it's with the people, because people need to come together, share their idea, share their thought, and then something good will come out of it. And we have seen that throughout the day. And there was a very inspiring talk by Dr. Ravi, previously, and he went over a lot of things that he had done with his champions of industry. So for me, obviously, as like anybody else, it started with skepticism. See how it's going to fare, how is it going to go forward, how is it going to impact me, and that naturally gives rise to desire to know more. And while I was researching on several different topics, including this one, my first encounter, there was this 3D printed heart model, and this was at our program. This was at our congenital heart surgery program. This was a patient who was born with just one ventricle. And then these patients typically need about 2 to 3 surgeries before they are 6, 7, 8 years old. And this is the patient whose heart is enlarged 2 times. It is before the second stage of the surgery. And due to complexities, it was thought wise that we create a 3D model, print it, and look at it before we actually go in. And at this point, I would like to say another disclosure that all the things which I'm going to talk about that I have experienced so far have been covered from morning till now. So I guess at some point you think that I have no new information to offer, and that is completely all right. So anyway, moving forward, how I use it. So a lot of things. One thing that we just covered about surgical planning, including that, the natural progression is medical education and patient education, because a lot of times if we explain patients better, they have more confidence in you. And then how we do this as a custom equipment design. So we'll go over one by one. And then there are other uses that other of the speakers have talked about, including AR/VR planning, other implants, and then biomaterial printing. So as we see about design and printing, the critical aspects of 3D technology in medicine, so design is key, and CT scan is vital. And as we experience in our program, this is the actual printed model of the first heart we showed you. This was all done in 2016 and 17 period. That's when, and since then we have been regularly doing it. But as Dr. Mahesh had mentioned, that we have also moved from printing it more to then using more an AR VR technology. So we don't need to print this as often as we used to. So here, the same patient we printed, we provided surgical hypothetical cuts so we can see what's inside, what are the fibroses happening between the first and the second surgery, and how much we need to dissect so we can provide the best solution for the patient. And then moving on, what are other, so this is a more recent use of what we have done. So if you see here, I guess mouse may not work, but the circle is actually a device. It's a heart pump. This is used in patients who are undergoing cardiogenic shock. Their heart cannot pump blood. So what we need to do is insert this device in the patients, and device is a pump that will pump the blood from that ventricle to the rest of the body. Now, this device is meant for adults and older and bigger kids. So this particular patient was an 8-year-old kid, only 15 kilos. But the patient was crashing and was probably, going to die in the next few hours. So we decided we can use this device to salvage the patient. So first we performed the CT scan, we did the 3D reconstruction, then we got the 3D images of this device from the company, and we superimposed the device 3D image on our 3D heart model to see whether the device is going to fit in the patient's heart or not. And then we also took some help from the company's engineer to go over the dimensions. And we also needed to see if the device was going to be inserted all right or not. So once we did that, the device was then implanted in the patients, and we were able to save the patient, and then patient eventually received the heart transplant. And we have so far done 12 of these patients. 6 of these patients were transitioned to another device which was long-term durable, and 6 of the other patients received heart transplant. Now, I have also been working, in surgical planning of this particular technology in knee surgery. We have seen customized knee implants available, and we have seen a lot of talks. They were all great talks. Now, how do we use it, right? So we are not implanting anything, but we are using the knee joint osteoarthritis. We are treating that by high tibial osteotomy. We call it a resto knee surgery. We don't completely take the bone out. We just take the anterior portion of the bone out, and then we override, tibia, and try to do the joint. So how we plan? Again, CT scan. We don't go for high resolution CT scan. We just go for normal CT scan. We don't ask for anything else. And then we do this 3D reconstruction with the open source software Slicer, and then we have done some modifications to open source software so that our 3D reconstruction is done faster. And then we have a facility who has a lot of experience in Ahmedabad, Melt Engineering. They handle all the prints, and then the models are then delivered to the surgeon, and then the surgeon is doing the actual simulated surgery on the bone models, and this is done on all their patients. It's not that they need to do it on one particular patient, and this is how it works. So this is the bone model. They need to take the wedge out. They need to calculate the angle of the wedge, the thickness of the wedge. So they need to print the model on all patients. And they print the model, they do the simulated surgery on the model, and then they take the wedge out. And they explain exact steps to the patients. So patients' confidence in doctor increases. And what we have seen is that because of this, the surgeon is being reinforced by patient, and that has resulted in over 97% compliance to the follow-up at 1 year. And this has increased the surgical volume by 70%. The hospital was doing about 8 surgeries a month. Now they are up about 15 surgeries a month. So since then the volume has even grown more. And so far we have done about 450 models to do 3D model and just do the surgical planning and simulation. And then what are the other uses of in my experience? So during COVID, we have all seen, we did print these 3D shields, and that's how we print 3D shields back in US and in here in my collaboration. We printed the 3D mask as well, and then idea came about doing a negative air pressure helmet, because a lot of these patients were kept in negative air pressure chambers. People were running out of space, so maybe the idea that this can be applied to patient. So as a doctor, I thought a box would be fine. Did realize that box is not going to stay on the head, so you need a helmet. So we came up with a proper design. Everything is 3D printed, and then eventually, after multiple testing, we now came up with this mask attachment with the battery that provides negative air pressure. And then we have received the National Science Foundation grant to further develop this particular product, and we are actually testing our prototype right now on this product and have a provisional patent. We have is in medical education, digital and hands-on. These are our hands-on experiences that we have had. We have printed this in soft material, and we now actually do the simulation labs for medical students, and particularly on the cardiac surgery sites, so they can actually learn how to use this material in the complex procedures. The one on the left you see is used by medical students as their first ever suture simulation lab. And then moving on to the digital, we actually have developed a anatomy learning app from the real life CT scans of the whole body. We have started with the bone models, and then we are actually working on developing the tissue models, and then we are actually allowing contributions from all the physicians who have ever used anything, so they can contribute pathology, normal, anything. So more and more people can come together, they can provide their input, other people can learn from what they have done. And then eventually we can go on to AR and VR solutions. And we have named this as anterior3d.com. This is the hand model that we have. What we have also done is, with the help of AI, we have superimposed Gray's anatomy on this model. So every time you touch a bone or a surface, it will provide you with all the information about that bone, attachments, blood supply, all those things are all part of this. The real thing, about democratization when we talk about this is cost considerations, because design costs are highly variable, and Dr. Banerjee can speak more on that one. Now, printing cost has become mostly predictable, but design cost, it depends. A lot of times it's missed and the hit. But anyway, and end user acceptance in medicine is evolving, and I can see that it's growing. So it's a good sign. But then scalability, right? That's an important thing. This is not a production. So scalability comes not by printing 100,000 models. Scalability comes by standardizing your processes. So you can print 100 models in exact same way, where you have your input decided, your process is the same, your output is decided. So in conclusion, applications are ever evolving. We see a lot of orthopedic applications now. I think it's going to move on, go into more things which we have not imagined today. And then with the help of AI, I think we can standardize these processes so that we come up with something that is beneficial to both, end users, that means patients and the surgeons. So I would like to conclude that democratization of 3D technology is happening, and we need to bring everybody together more and more, so we can say that this is my 3D printed heart and this is my 3D printed hand. And I think we are not far from that. And I want to thank you, and